In this video, I'm taking a look at writing equations of transformed functions. And you'll notice that what we're given here is we're given the original parent function and we're giving a transformed function down here. And basically we're going to be combining those two. And I'm just writing the equation that I get from applying all of this stuff to that parent function. All right. So a great way to think about this is start by just writing down your parent function. So that's 1 over x. And we're just going to start building on it here. So the very first thing you see written over here is that -5. That -5 is being multiplied by f of x. So I'm going to go ahead and just write that -5 being multiplied out front of it right there. And then the next thing I see as I'm reading this problem up here is the x plus 4. Now notice that the plus 4 is in the parentheses with the x, which means that I'm going to have to put x plus 4 wherever I had x in the original equation. So instead of it just being 1 over x, I'm going to make that into x plus 4, and I want to make it really clear that the whole thing, that whole x plus 4 is in the bottom of that equation since x is in the bottom. All right, then the last thing in this transformed equation is the -3. And so for that, I'm going to need to then put a -3 hanging on the end. Now, while this is technically done and correct, it doesn't look very pretty at the moment. In particular, this -5 just being multiplied out front, we could actually tidy that up just a little bit. It's better form more than anything to go one step further. And so instead of doing -5 times 1 over x plus 4, I'm going to write that instead as a -5 over x plus 4. And you notice the -3 is still just hanging out there. The reason is because if I do 5 times 1 here, that gives me the 5. And anytime you're going to be getting a negative, we tend to just write the negative in front of the fraction rather than writing the negative in the top of the fraction. We just say, okay, the fraction then is a negative fraction. And so then I would call this your final answer. We can apply the same method to this problem here. This time, though, we're starting with a logarithm equation. What's that change? Nothing really, except for a few details about what we write. Otherwise, writing the transformations as we have them described here are going to work pretty much the same way. So, first thing I'm going to do is I'm just going to write down log base 2 of x. And now that I have that, I notice that the very first thing I have in my function over here with the transformations is the 4. And so that 4 is being multiplied by it, so I'm going to multiply this whole thing by 4 as well. Now you have an option where you could just write it like that, as 4 log base 2 of x, or you can write it as 4 times log base 2 of x with the multiplication symbol in there. However, the multiplication symbol isn't really changing anything there, so I'm just going to go ahead and leave it out because it looks a little bit tidier. All right, next thing in my transform function up here is I see the x plus 9. Now notice that that x plus 9, it's contained within the parentheses. So that's telling me that wherever there was an x in the original equation up here, I'm going to be replacing it with x plus 9. So I'm going to have to move that second parenthesis that I have sitting there. And I got to make room so I can write that instead as x plus 9 inside of the parenthesis. And now I've dealt with the x plus 9 part, which leaves me only with the plus 5 hanging on the end, which I deal with by putting a plus 5 on the end of my equation. And now I have written my transformed function. So whereas previously we were just looking at it in the function notation, now you should be able to see the connection between the parent function, the transformed function and function notation, and the actual transformed function actually with the equation itself in there.